Alright, so this is by far the toughest section in Chapter 7 because there's three different types of shapes, really two different types of shapes with one little twist on one of them. But this is the most challenging part of this chapter. Alright, so it starts out with something called a trapezoid. A trapezoid is a quadrilateral, so it's a four-sided shape, so quadrilateral. It's a quadrilateral with exactly one pair of parallel sides. This side and this side are parallel to each other. The other two sides are not. The other two sides are not parallel, they're not congruent, they're just there. The top and the bottom are parallel to each other. Those parallel sides are called the bases. So this is a base, and this is a base. Okay? So the top and the bottom, or the parallel sides, are bases. So even if it's turned on its side, even if it's flipped, even if it's changed a little bit, the parallel sides are always the bases. Okay? So now, these things right here, I'm just going to erase and kind of fine-tune a little bit. These things right here are called the base angles. Okay? Base angles is a pair of angles that is on either side of the parallel bases, which also means that these, actually I'm going to do that in a different color. That also means that these are base angles, but they're different base angles. Okay? This thing here is called a leg, and this thing here is called a leg. The legs are the non-parallel sides. That's what a trapezoid is. A trapezoid is pretty tough. There's a lot of stuff going on with it, and there's a lot of things that we have to try to figure out. Okay? But that being said, there is one easier trapezoid to deal with, and this is called an isosceles trapezoid. And an isosceles trapezoid is a trapezoid with congruent legs. So the top and the bottom are still parallel to each other, but these two things are congruent to each other. Okay? So that's a little bit easier. A kite is a quadrilateral with two pairs of consecutive sides that are congruent. Again, if I were you, I would try not to pay attention to the words as much as I pay attention to the pictures. The pictures are going to make a lot more sense. Typically with these types of things, if they look like they're the same, they probably are the same. So like in the kite, look at the two sides that look like they're the same. If you know this thing is a kite, then you know that those two sides are congruent to each other. Okay? So when you deal with this, just understand that the two sides means that the two consecutive sides means that they're congruent to each other. Okay? Now we get into some theorems. This is where things get a little bit dicey. Okay? So a trapezoid is isosceles. If a trapezoid is isosceles, then each pair of base angles is congruent. So if I know the trapezoid is isosceles, then I know that these are going to be congruent. Okay? So if you need to write that down, pause it. I'm going to move on. The next one. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. That's pretty much the exact same thing. If I know that these two angles are the same, then I know right now that those two sides are going to be the same. Okay? I also have to know this is a trapezoid, so those have to be parallel. Okay? And then finally, a trapezoid is isosceles if and only if its diagonals are congruent. So this thing, if it's an isosceles trapezoid, then that means that these diagonals right here, so I'm going to write diagonals congruent. It means that those diagonals are congruent. Now, one really important thing that I'm going to mention to you right now is just because these are congruent does not mean at all, does not mean that this piece and this piece are the same. They're not. Okay? Now what we can say though, and this is something that we could prove later, this side up here and this side up here, those ones are the same. And this side down, hang on, and this side down here, and this side down here, those sides are the same. So, dealing with that, you can deal with that how you want, but those are going to end up being the same. Okay? The next thing, oops. The next thing is the mid-segment theorem. We've already dealt with the mid-segment theorem once. I apologize. I don't know why that shape did that. But what we're going to do with this is we're just going to basically reiterate the mid-segment theorem. So the mid-segment of a trapezoid is parallel to each base, and its length is half the sum of the bases. So this thing is called a midsegment. That means that it breaks these up into two equal pieces because it connects midpoint to midpoint. This thing up here is base 1. This thing down here is base 2. The midsegment equals half of base 1 plus base 2. We'll see an example of what that looks like in a second, but that's what that means. Okay? It also means that all three of these are parallel to each other. Okay? Finally, we're getting to kites. If a quadrilateral is a kite, then its diagonals are perpendicular. So these right here, and they look like they're perpendicular, right? If you've ever flown a kite that looks like this, you know that it has two supports that go from corner to corner, and that means that they're perpendicular, right? And then finally, the last theorem is if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent, and it's obviously not these two pairs. Those two pairs don't look like they're the same, so it's these two pairs. Those two pairs are the ones that look like they're the same. Okay? So that's all the theorems. Now it just turns into marking the picture up as much as we possibly can. Once we mark the picture up as much as we possibly can, then we have to start doing examples. So again, those the things that we just did were super important, but this is going to be the most important part for you. Okay? This is what the pictures look like when they're marked up. So this is a mid-segment, which means that it breaks these into equal pieces. This up here is base 1. This down here is base 2. The mid-segment is equal to half of base 1 plus base 2. That's the picture you need to remember. Okay? If we're looking at isosceles trapezoids, parallel, congruent, congruent. These up here are congruent. And also, I'm going to put this part in red because we have diagonals. And I'm just going to put that down here. Congruent diagonals. Now, this is something that you have to know. Okay? So this is a picture. I would memorize the picture. Maybe not memorize, but just have the picture handy every time you're doing one of these things. Okay? And finally, the last one is a kite. And when we're dealing with a kite, we know a couple different things. Number one, the consecutive sides are congruent to each other like this. We also know that opposite angles are congruent. We also know that these are perpendicular to each other. And then finally, I know a couple different things. These are things that I'm telling you. You might not know this, but I'm telling you this. This angle is bisected up here, so those are congruent. This angle down here is bisected, so it's congruent. And then these are congruent. Okay? Notice how much stuff there is going on in a kite. Just pay attention to that. Make sure that you're ready for it. Okay? So now it just becomes examples, things that we have to be able to come up with. I'm going to go through one example of an angle with you. It doesn't really matter which one we go through, but when we deal with this, let's just look at the third one. If you look at the third one, notice that we have an isosceles trapezoid. These are the bases here, because they're the sides that are parallel to each other. These are the legs here because they're the sides that are congruent to each other. So I know from an isosceles trapezoid, if you turn your paper, these are all going to be the same, which means that this one's going to be 97, and now these two things have to be the same. I know that a quadrilateral has 360 degrees. I'm taking away 97 of those, and then I'm taking away 97 more of those, and if I take 360 minus 97 and 97, I'm left with 166. So these two angles that I have circled up here, sorry if you can hear that car going by, my window's open, those two angles right there have to add up to 166. So I'm just going to divide it by 2, and that tells me that each of these are going to be 83-degree angles. Okay? You've got 3 more of those to try. The next one is, I'm going to do 2 of these ones. Okay, so the next thing, this is using the midsegment theorem. So I know the midsegment, x, is equal to, now this thing is always the midsegment. That's the thing that's going to be equal. So it's going to be x equals 1/2, and then it's going to be base 1 plus base 2. That 4 has nothing to do with anything. Okay, so it's going to be x equals half of 9 plus 3 is 12, and half of 12 is 6. Now the thing that could get a little bit trickier is this. This side has specifically given you the midsegment. So midsegment 12 is equal to half of base 1 plus base 2. Now this one's a little bit more challenging. There's two ways to solve this, but I'm going to go with the way that most of you probably are, and I'm going to distribute these two numbers here. So it's going to be 12 equals half x plus, and then 1/2 times 8 is 4. I'm going to subtract 4 from both sides, so I get 8 equals 1/2 x, and now to get rid of that, I multiply by 2. So x is going to equal 16. Okay? So that's two of those questions. You have one of each of those to try. I left one of each of those for you to practice, so that way you can see whether you do it right or whether you do it wrong. Okay? And the very last example that we're going to go through is about the... I lost my pen. Hang on. Be right back. So the last example we're going to go through is using the Pythagorean theorem to find certain things out. Now, every single one of these is the exact same. We're basically trying to figure out all of the lengths of the entire thing in the kite. So basically I need to find this length here, I need to find this length here, and I need to find this length here. Now it's easier to start out with one than some of the other ones because sometimes you are given information. Like for instance this is 20, which means that this is also 20. So that means that this in here is 20. So now if I look at my big picture, I know this is 48, I know this is 20, so now I can find that. The way that I'm going to do this is I'm going to use 48 squared plus 20 squared equals x squared. So that's the way I'm going to do that. When you go through all of that math, you end up finding out that x equals 52. Okay? That tells me that this is 52. Now remember, top and the bottom are congruent to each other, so I've already found those sides. Okay? So I've already found the sides in the middle. This side up here is 20. This is 52. This is 52. So now I just have to find this piece right here. So I'm going to erase my work down here. If you need that, pause it. So now I'm going to look at this smaller triangle here. This side is 21, this side is 20, this side is x, so it's going to be 21 squared plus 20 squared equals x squared. When you do all that math, you end up finding out that x equals 29. So that means this is 29 and this will be 29. Okay? So, you have lots of problems to practice. Answer key is posted. If you have any questions and want to see anything after you look at the answer key, please make sure that you let me know. Otherwise, we'll see you for the next chapter. Next chapter is going to be chapter 11, and that will be the last chapter in geometry that you ever have to go through. Alright, we'll see you.